Grade 12s, we're continuing with exponential functions and another method to solve. You'll notice day after day we're solving, just with different methods. So from yesterday, we had methods to solve. Number 1 was by inspection. So for instance, if 3 to the x equals 9, you're allowed to just look at it and say x is 2. Because 3 squared is 9. Number 2, we can look at a graph. If you have your graphing calculator in your back pocket at a party, and we want to know 3 to the x equals 29, that's not so pretty. So we can put the graph of y equals 3 to the x into your calculator. It has a 1, 3, 9, 27. You can trace on a calculator, you can zoom and determine the answer. Would be approximately about 3.1. Third is we can do trial and error. So if 3 to the x equals 36, we can say, all right, I know 3 cubed is 27, and 3 to the power of 4 is 81. So it's definitely between 3 and 4 and closer to 3. And so we can guess away till we get to the right answer. It's kind of similar to inspection and not the best method. Today we're going to look at an algebraic method if we can change to the same basis. So for instance, 3 to the x equals 27. We know the answer to that one. The reason is I can rewrite 3 to the x, and I can rewrite the 27 as a power of 3 as well. So since 3 to the x equals 3 cubed, then our x must be equal to 3. Example number 2, I have different bases, but I can write the 8 as a power of 2. So 8 is the same as 2 cubed. So if those two bases are the same, then the exponents must be the same in an equation. So 3x minus 4 must be equal to 3 for that to be a true statement. Those you know how to solve. Add 4 to both sides. Divide both sides by 3. We have our solution. For the one at the bottom, example 3, I have 4 to an exponent and 8 to an exponent. I cannot rewrite 8 as a power of 4, but I could rewrite both of them as a power of 2. So I'm going to replace the 4 with 2 squared. I'm going to replace the 8 with 2 cubed. And I'm going to simplify. My rules of powers state that I have power of a power I would multiply. This is also power of a power, 3 times x minus 3, 3x minus 9. Be careful with those. If I have the same base in an equality, that means the two exponents must be the same. So 6x must be equal to 3x minus 9. To solve that, I'm going to subtract 3x from both sides and divide both sides by 3. Sorry, that's an x. X equals negative 3. Example number 4, I have two powers that can both be written as powers of 3. So 3 to the 7x minus 3 exponent equals, I'm going to rewrite that 81 as 3 to the power of 4. You leave it in brackets, you often can avoid power of a power rule errors. 3 to the 7x minus 3 equals 3 to the, multiply the exponents, 4x. The bases are the same, therefore the exponents must be the same in an equality, so 7x minus 3 is equal to 4x. Subtracting 4x from both sides, adding 3 to both sides, I have a final answer of x equals 1. Example 5. This one is kind of ugly. It's a mixed number, first of all, and that's just making me a little squirrely. On the right side, it's 2/3. But because I have a mixed number on the left side, I'm going to change that to 9/4 x. And at least I have two fractions I can compare. Notice the 9/4, could be written as 3/2 squared to the x. And that could get me to 2/3 because it's just 2/3 upside down. So if the left side is 3/2 to the 2x, and I need to have the same base on both sides, I'm going to rewrite the left side as 2/3 to the negative 2x. A negative exponent will allow me to flip. Now both have the same base of 2/3. And in an inequality, if the bases are the same, then the exponents must be the same. I want the x's on the left side. I'm going to subtract 2x from both sides, divide both sides by -4, and I would get a positive 7/4. And another ugly one. I have the root of 128 to the 2x minus 7. The Smart Notebook isn't making it any easier to deal with either, so I'm going to write this as 128 to the 1/2. That's what a square root is, to the 2x minus 7 equals. Well, let's at least write the right side so that I can see it. 1 over the cubed root of 8 to the x plus 5. Okay, that's a little better. The right side is something on the bottom, so if I write it with a negative exponent, and it is a cubed root, so if I write it as 8 to the negative 1/3, I don't have that root that's quite so ugly. 128 to the power of a power would say multiply, so I have a half times 2x, which is just x, a half times 7, which is 7/2. All right, I have two very different bases, 128 and 8. I can't write 128 as a power of 8, but I could write both of them as powers of 2. 128 is 2 to the 7. 8 is 2 cubed. Wow, it's ugly on the left side. I have power of a power. That means I multiply the 7 times x minus 7/2. I will have 2 to the 7x minus 7 times 7/2 is 49/2. So not a lot prettier. On the right side, I have 2 to the 3 times minus 1/3 is -1. Almost there, honest. 7x minus 49/2. 2 to the power of a power, multiply the exponents, I get -x, -5. Now I have an equation with the bases the same. That means the exponents must be the same. 7x minus 49/2 equals -x, -5. Same process, I'm going to add x to both sides. I'm going to add 49/2. And since I'm going to be adding two things, I need a common denominator. I'm just going to make my 5, my -5, as -10/2. 8x equals 39/2. Divide both sides by 8, 39/16. Bet you didn't know that answer by inspection. Let's do a couple more. I'm throwing some tough stuff at you today. Recall from last year, if you have x squared plus 5x plus 6 equals 0, and we wanted to find answers for x, well, this is from the beginning of our semester as well, we can factor to find x-intercepts, which would be solutions to this problem. So this one factors very nicely. X plus 3, x plus 2 equals 0. So x equals negative 3 or x equals negative 2. If you forget, I got those two answers by setting first one bracket and then the other equal to 0. Either scenario would give us a 0 answer, so subtracting 3 from both sides, x equals negative 3, or subtracting 2, x equals negative 2. Likewise, this hideous thing is the same as 2 to the x squared, because you'd multiply exponents and get what you started with, minus 5 times 2 to the x plus 6 equals 0. That's very similar to the equation we had above. That would really be the same as a squared minus 5a plus 6 equals 0. And that we can factor. A simple trinomial multiplies to 6 and adds to negative 5. We could factor that easily enough. We can do the same with this one. It would factor as 2 to the x, take away 3, 2 to the x, take away 2 equals 0. So our two solutions would be 2 to the x equals 3, or 2 to the x equals 2. I'm going to do the easy one by inspection. For this one, x is 1. For this one, I would have to use a graph or estimate and guess. X is approximately 1.58. All right, let's try some. Page 70.